Hi everybody, my name is Mr. Frensley and I teach AP Physics. But AP Physics involves a fair amount of what they teach in AP Precalculus. So I figured today I would have a look at the AP Precalculus free response questions for 2026 that were just released yesterday. And I did not have a look at this beforehand, so I'm going to be running these cold, and I hope I do a good job. All right, here we go. This is the S calculator portion. All right, so the function g is given by that. Well, this is not g, this is f. The function h, oh wait a minute, the figure shows a graph of increasing function f on this domain. And g is given by WTF, whatever, okay. The function h is defined by h equals g composed of f of x. Okay, that's another way of writing it. Find the value of h of 2 as a decimal approximation or indicate that it is not defined. Yeah, it's going to be defined, I'm pretty sure. Show the work that leads to your answer. Okay, so h of 2 is going to be g of f of 2, and f of 2 is 5. So then I need to do g of 5. Well, that means I'm going to do negative 4.792 plus natural log of 6 times 5 minus 6. Okay, so here we go. Let's erase all this extra stuff from when I did the AP Calculus bullcrap. Negative 4.792 plus natural log 6 times 5 minus 6. And I get a decimal approximation of negative 1.614. Okay, that was part A. I'm going to try and do some different colors on each part. Hopefully you can see these. Okay, find values of x for which f of x equals 3. Are you for real? Okay, at x equals 9, f of x equals 3 because 3 comma 9, sorry. 3 comma 9 is on the graph above. All right. Oh, nope, I did it wrong. All right, this tells you what happens when it's after school and I just finished out my grades, so my brain is not working. Let me try that again. Okay, it's actually 1 at x equals 1. Okay, let's try to not make really rookie mistakes like that. F of x equals 3 since 1 comma 3 is on the graph above. Okay, that's the only one. That's the only place where f x equals 3. Okay, wow. They're off to a great start today. All right, find all values of x as decimal approximations for which g of x equals negative 1.5 or indicate that there are no such values. Okay, well, you know something? You can use a calculator and like calculate an intercept or whatever, but you can also just go ahead and solve it. Negative 1.5 is equal to negative 4.792 plus natural log 6x minus 6, okay? So what are we going to do? I'm going to take negative 1.5, I'm going to add to it 4.792, okay? So 3.292 equals natural log of 6x minus 6. So we're going to e up both sides. So we're going to take e raised to this number, okay? 26.897 is equal to 6x minus 6. So let's add 6, and then let's divide by 6. And I believe x equals 5.483. And I think that's the only one. That is the only value of x for which g of x is equal to negative 1.5. I hope I got that right. Okay, determine the behavior of g as x values increase and get arbitrarily close to 1. Okay, well, I mean, you gave me a calculator. I might as well just use it. Okay, so I'm going to do negative 4.792 plus natural log. What's going to happen is as x approaches 1, the inside of the natural log is going to approach 0, and a natural log has an asymptote at 0, right? Okay, so let's do a zoom here. All right, so it looks like that the end behavior is approaching negative infinity. So as x values decrease and get arbitrarily close to 1, using limit, so limit as x approaches 1 from the right-hand side, because it says as x values decrease, so I bet you had to do that. G of x is equal to negative infinity because, and that's my wacky infinity symbol because it goes way the frick down right there. Is the function f invertible? The answer is yes, because, so what do you want me to say here? Okay, so for CI, yes, it is invertible, and maybe you can say it passes a horizontal line test, right? No horizontal line can be drawn that intersects the graph twice or more. Okay, so there you go. Give a reason for your answer in part CI. Well, I guess I just did it. Based on the properties of function f, refer to points on the graph f in your reasoning. I think that's CII right there. That was my reasoning. Okay, so there you go. All right, 2. A person purchased a car at the end of the year 2019. The car's value decreases over time. At the end of the year 2020, the car was valued at that many $1,000, and at the end of this year, the car was valued at so many $1,000. The value of the car can be modeled by this function, ab to the t power, okay? Use the given data to write 2 equations that can be used to find the values of the constants a and b. So what I'm going to say is I'm going to say this. I'm going to say v equals ab to the t. So value 27.2 equals ab to the 1 power. And we're going to say this 14.8 equals ab to the 6th power. Okay, do you see how that's working? You see how that works? All right, I think I got that right. Find the values of a and b. I knew that was coming. All right, so I think what I'm going to do is I'm going to do this crazy thing. I am going to take 14.8 equals ab to the 6th power and 27.2 equals ab to the 1 power, and I'm actually going to divide one equation by the other. Why am I dividing one equation by the other? Because there's no plus or minus. It's all times an exponent, and division can cancel out times, like you can cancel out this a. And then 6, b to the 6th over b to the 1 is b to the 5th, and then I'm going to say, okay, so 14.8 over 27.2. This is a trick we do in physics a lot. Okay, and so I am going to take the 5th order root of this number. Okay, so b to the 5th is 0.544, so b itself will be 0.889, okay, all good. All right, then I'm going to come back up here, and I'm going to say 27.2. Oh, by the way, I'm just going to let you know that I did not convert these to thousands, and the division would come out the same if you convert to thousands. But now what I'm going to do is I'm actually going to do 27,200 like that. Okay, so 27200 equals a times 0.885 raised to the power of 1. Okay, so I'm just going to divide by this to the 1 power, and I get 30,720.64. It's money. Do I have to have a third decimal place? It's money, okay? And that is a number of dollars, by the way. That's a dollars. This is a base that has no units. Yes, I did. Did I say I was a physics teacher? I care about units. Units matter to me, all right? Now, I'm going to do one other thing. I'm going to play a game called What Happens if I put in, time 1 and time 6. And then here I put in 27,200, and what was that other number up at the top there? 14,800. And then I do something in my calculator called an exponential regression. Okay, so I push the button stat. Here, let me show you what I'm doing. I push stat, edit. I put in time. VV for value. I go to stat calc, and then I go to exponential regression. L1 holds the x's, L2 holds the y's or the v's, and then there's your a and there's your b. See, y equals ab to the x. It has the right form. Not power regression, exponential regression. Okay, I did that. All right, use the given data to find the average rate of change of the value of the car in thousands of dollars per year from time 1 to time 6, okay? So average rate of change is the function's value at 6 minus the function's value at 1, all over 6 minus 1. So that's going to be 2. 7,200 minus 1,4,800 over 6 minus 1. Okay, so 2,7,200 minus 1,4,800 over 6 parentheses, 6 minus 1, okay? So it's going to be $24.80 per year, okay? Use the average rate of change found in part BI to estimate the value of the car at time 3 years, okay? So what I'm going to do is I'm going to imagine, I don't really actually know how to do this, so I'm going to guess. I'm not guessing. I know what I'm doing, but I don't. It's tricky for me. So the value of the car is decreasing. Here is 1. Here's 6. And here is a line connecting them. This is the line connecting them. So what we want to know is the value on the line at time 3. So the way I'm going to do that is I'm going to say y minus, what was this, 27200, y minus y1 equals, this is a slope, and it is a negative slope, 2, 4, oh, I'm sorry, I got these switched. This is supposed to be negative and positive. That is a negative because we're decreasing, okay? So that's a negative because we are decreasing, okay? Because the function is decreasing as a negative average rate of change. So y minus y1 equals slope x minus x1. So that is the y1 and the x1 of this point. And then that red line is this equation right here. So I'm going to plug in 3. Y minus 27200 equals negative 2480. 3 minus 1. So then I'm going to say, what is negative 2480 times 3 minus 1? Okay. Then I'm going to add over. I'm going to add over 27200. I'm adding it over, and I get a y of 22240 at time equals 3. Okay, so the value is about this much dollars at time equals 3. Okay. The average rate of change found in part BI can be used to determine the secant line. Did I just do that? I should probably read the whole thing before I actually do it. Let A of t represent the estimate of the value of the car at time t years using the secant line, which is what I did. For A of 3 found in B2, it can be shown that, yes, I showed it. The secant line is red. A is the secant line is greater than V. Okay. In general, A is greater than V for all t from 1 to 6. Use the secant line of the graph of V to explain why this is true. I think what they're trying to get at, and I'm not sure, but I think what they're trying to get at is this. Since V of t is concave up, any for all time, any secant line connecting 2 points on the graph will be above the graph. So is that what they wanted to hear? They wanted to hear that the secant line is above the graph itself because it's concave up? Because that's why. It's because of the upward concavity. All right, when the value of the car reaches $2,000, which is quite a bit in the future, but not too far, the car's owner plans to donate it to an auto mechanics school, okay? Don't donate it to Cars for Kids. It doesn't actually go to needy kids, all right? So I know they have a fancy jingle, but that money does not go to needy kids, okay? Do your research. Go look it up on Wikipedia. As a result, the car will immediately lose all of its value. Explain how this information can be used to determine a domain limitation for the model V, okay? So when V of t is equal to 2,000, then that is the rightmost value of t that can be in the domain of the function v of t. Okay, in fact, hey, let's just find out what the frick it is. Okay, so where's my a and b? Okay, so I'm going to go call back my a and b by going to vars on the calculator, vars, statistics. I did not mean that. Vars, statistics. You can tell I don't go there very often because I don't think to do that. There's my a. See, I keep going to y vars because that's what I have the instinct to do. I use y vars a lot. Okay, there's my b. Okay, so if $2,000 is equal to a b to the t, then 2,000 over a equals b to the t, okay? And then the natural log of 2,000 over a is equal to t times the natural log of b. So t is the natural log of 2,000 over a divided by the natural log of b. Okay, did you follow all that? So now I'm going to take the natural log, And you could do it with a common log too if you really, what? Where's the natural log? Okay, here's a natural log, okay, of 2,000 divided by my A. Where's my A? Okay, divided by the natural log of, where's my B? Okay, both these will be negative, so negative over negative is a positive, that'll be 22 years. So this is at t equals 22.444 years, so the domain is 0 is less than t is less than 22.444, since you can't have car value before buying or after donating the car. Okay, now the next bit is no calculators. I am going to just keep my calculator handy because I feel like I might refer back to it even though you didn't get to on a real AP exam. The figure shows a circular water wheel that rotates in a counterclockwise direction. A constant rate completes one full revolution 10 seconds. That's 2 pi radians in 10 seconds, just for future reference. I know where this is going because what did I say I teach? Physics, and this is just rotational motion, okay? Time 0, point W on the edge of the water wheel is at a height 6 feet above the center of the water wheel, okay? So that's 6 feet. The height of the point W from the horizontal line through the center of the water wheel periodically decreases and increases because that's what it is, a periodic function. The sinusoidal function h models the height of the point wheel from the horizontal line through the center of the water wheel in feet, function of time t in seconds. A positive value indicates W is above the line, negative is below the center. Okay, great. The graph of h and its dashed midline for 2 full cycles is shown. 5 points, F, G, H, K, J, K, and P, are labeled on the graph. No scale is indicated, no axes are presented. Determine the possible coordinates, T, H, and T, for each of the 5 points. Okay, so here's what I'm going to say. For F, I think that is going to be time equals 0, height equals 6 feet. Okay, why? Because that's where you start. You start at a height of 6 feet. Yeah, okay. Yeah, H is the height of point of W from the horizontal line passed through the center. Okay, so yeah, so this midline is actually 0. So this is 6 feet, 0 feet, and this is going to be negative 6 feet from the center of the wheel. Okay, F, G, J, K, and P. Okay, here we go. So this is going to be 0 feet, negative 6 feet, 0 feet, 6 feet. Okay, but what is the time? What is the time? Okay, so what did we hear? We heard 1 full revolution in 10 seconds. So if this is time 0 and this is time 10, because that's 1 full revolution, then this is time 5, and then this has to be half, so 2.5 and 7.5. Okay, so there you go. So I'm going to say 2.5 seconds, t equals 2. I don't know what they want. 5 seconds, t equals 7.5 seconds, and t equals 10 seconds, and then this is h equals, h equals, h equals, and h equals. I don't know if they want that or if they just want 0, 6 or what. The function h can be written in this form. Find the values of these constants. A is 6. That's the amplitude. B is 2 pi over the period, so that's 2 pi over the 10 seconds for 1 revolution. So A is 6 feet, B is pi over 5 radians per second, okay? Oh, shoot. Gosh. And so now I've got to be careful because I need to start with cosine. I need to start with cosine. So I need B times C to equal pi over 2. So I need B, I'm distributing. So B times C is equal to pi over 2 because I need this whole thing to make pi over 2. So I start like cosine starts. Sine of pi over 2 is like cosine at 0. So that's going to be pi over 5C equals pi over 2 because I'm distributing. That's why B times C has got to be pi over 2. So then that means that C is 5 halves or 2.5, right? And then D is 0 because you're on the center line. All right, refer to the graph of H in part A. The t-coordinate of J is T1 and the t-coordinate of K is T2. T1, T2. Okay. On the interval from T1 to T2, which of the following is true about H? H is increasing, but H is negative. H is negative, and H is increasing. Okay, does it ask me to explain why? Okay, why is it negative? Because the function is literally below 0. Why is it increasing? Because the function is going up higher and higher and higher. Describe the concavity of the graph. Okay, so it's concave up because it looks like part of a smile, and determine whether the rate of change is increasing. So H's rate of change is itself increasing. And why is that? Because the slopes are getting steeper and steeper. The rate of change is the slope. They're getting steeper and steeper. Okay, I didn't need a calculator for that. Okay, unless otherwise specified, the domain of a function f is assumed to be the set of all real numbers x for which f of x is a real number. Angle measures for trigonometric function are assumed to be radians. Solutions to equations must be real numbers. Determine the exact value of any expression that can be obtained without a calculator. Well, you don't get a calculator, okay? Can be evaluated without a calculator. Unless otherwise specified, combine terms using algebraic methods and rules for exponents and logarithms. Okay, whatever. Sure. Okay, for each part of the question, show the work that leads to your answers. Functions g and h are given by these two efforts. Suppose g of x equals 1 over e to the 6th for values of, solve that. Okay, so e to the 2x equals 1 over e to the 6th for values of x in the domain of g. E to the 2x is equal to e to the negative 6, because that's what that is. 2x equals negative 6, x equals negative 3. That is most certainly in the domain of g, because the domain of an exponential is all real numbers. Solve h3. H equals 3. So 3 equals log base 2 of 5x. The opposite of log base 2 is 2 raised, okay? 5x, that's going to be 8 equals 5x, so x equals 8/5. This feels too easy. The functions j and k are given by this bullcrap. Rewrite j and k as an expression in the form of 7 raised to an expression. So I'm going to say this. I'm going to say 7 to the 3x plus 1 plus x, because that you just add. So then 7 to the 3x plus 1 plus x. This is going to be 7 to the 4x plus 1. Okay, that's j, a function of x. Rewrite k as an expression which sign appears exactly once and no other trigonometric function. Okay, so basically you're taking sine of 2x times secant x, and you're supposed to say that sine of 2x is 2 sine x cosine x, and then you get your secant x right here. But cosine and secant are reciprocal, so they die out, so you just get 2 sine x because these are reciprocals of each other. All right, we're just having a function party today. Functions all over the place. The function m is given by the tangent squared of 3x. Find all input values of m on this interval that yield an output value of 1. Okay, so in other words, 1 is equal to tangent squared 3x. That means that plus or minus 1 is just tangent of 3x, because that is, when you take the square root, it's plus or minus 1. So then I'm going to sit here and say this. I'm going to say what gives you a slope on the unit circle. Remember, that's what tangent is it's the slope. So that's going to be the following: pi over 4, and then 3 pi over 4, 5 pi over 4, and 7 pi over 4 all give you a slope of 1 or negative 1. So I'm going to say 3x is equal to, let's just call it pi over 4 times 2n plus 1, and n can be 1, 2, 3, or 4. No, 0, 1, 2, or 3. That works for me, okay? So now I'm going to divide. I'm going to say x equals pi over 12, 2n plus 1. Okay, so now actually I actually need to plug in every possible n that outputs something that is between 0 and pi over 2. So here we go. Okay, so I'm going to say pi over 12, and then, okay, all right, so pi over 12, that's, oh, sorry, I meant to do this n. N is 0, n a 1, that's going to be, okay, 3 pi over 12, and I won't simplify it yet. Okay, and then n equals 2 is going to be 5 pi over 12. That's still less than pi over 2, and I think that's it. The next one will be 7 pi over 12, and 7 over 12 is more than a half. So I'm going to say x equals pi over 12. I'm supposed to simplify, so pi over 4 and 5 pi over 12 all make tangent squared 3x equal to 1. All right. End of exam. Pre-cal is not too difficult in my opinion.